Okay, everybody, welcome to R5. R5 is rational expressions. R5 is the last section before our first unit test, okay? So let's finish strong, and if you need to, let's go back and revisit some of the older videos and make sure we understand everything. So R5 is rational expressions. Simplifying rational expressions is the first topic we're going to look at. The idea behind simplifying rational expressions is to factor, then cancel. Factor, then cancel. That's the name of the game. A rational expression is really, it's just a fraction, right? But in that fraction, we have a polynomial on top and a polynomial on the bottom. So when I look at it in this form, it's in standard form right now. Notice the degrees go from biggest to smallest. But in order to simplify it, we want to put it into a factored form. So we're going to put it in a factored form right over here. Now, I want you to remember, R4 is pretty tough. The factoring unit was pretty tough. I get it. We got to get good at factoring, though. So I really strongly encourage you to use your handy-dandy factoring guide again and again. Know it backwards and forwards. That way you can look at a polynomial and know exactly how to factor it. So let's look at the numerator. Look at the numerator on top. We would try for a GCF, but there is no GCF. There's nothing to factor out first. So we go to the size, it's a trinomial, right? So we look at all the trinomial factoring. It's quadratic. The leading coefficient is not 1. So we should know what method is. That's going to be the AC method. We're going to use the AC method to try to factor that. All right, so first off, A times C equals -8. B equals 7. What multiplies to -8 and adds to 7? That would be 8 and -1. 8 times -1 is -8. 8 plus -1 is 7. Now remember, the next step is to put those numbers that we found over the leading coefficient of 2, over 2, over 2. And then we have to simplify our fractions. Well, this one's already simplified, so that one's good to go. This one that's 8 over 2, we're going to simplify that to 4 over 1, and now that one's good to go. Now, if you remember from here, we take the denominator and we bring it to the front. So my factor is going to be p plus 4. My other factor is going to be 2p minus 1. So again, unfactored form equals, and then we're going to write here the factored form that we get. So I have p plus 4, and then I have 2p minus 1. How can I factor the bottom? It's a binomial. What's the type of factor I always have to do first? Yes, GCF. So is there a GCF? Yes, there certainly is. They both are divisible by 5, so we're going to pull out a 5. And they both have a p in it, we're going to pull out 1p. So I'm going to have 5p on the outside, and then left over, I'm going to have p plus 4, okay? So now, look, I have a factor of p plus 4 and a factor of p plus 4. So I can cancel this factor and this factor. And I am left with 2p minus 1 over 5p. And that's it. Now, sometimes people are going to try to be tempted to cancel this p here, this p here. You can't cancel that p. If it's separated by subtraction or addition, it's term, not a factor. This 2p is a term. I cannot cancel this p and this p. It has to be its own separate factor, separated by nothing but multiplication. So since it's subtraction in between the 2p and the 1, we cannot cancel those p's. And this is our final answer, okay? All right, I want to simplify one more. So I'm going to erase this one. All right, here we go. 6 minus 3k over k squared minus 4. What's the name of the game? Yep, you guessed it. Factor, then cancel. Factor, then cancel. Look at the top. How can I factor it? Well, it's a binomial. Definitely not a difference of squares. Definitely not sum or difference of cubes. The only thing I can think of is GCF. What is the GCF? Yep, 3. Both terms are divisible by 3. I'm going to pull out a 3, and then I'm left with 2 minus k. Look at the bottom. It's a binomial. There's no GCF, but it's a difference of 2 perfect squares. It's a difference of 2 perfect squares. So that will factor 2. And remember, difference of squares is super easy. It's always 2 binomials, right? 1 is plus, 1 is minus, and we're going to take the square roots of each of these. So we get k plus 2 and k minus 2. Does anything cancel? Not yet. Look, I got a k minus 2 and a 2 minus k. This is a special problem. I picked this one on purpose. Whenever you see something like that, you can't just cancel it. But what if I factored a -1, because you can always divide things by -1. What if I factored out a -1? What would happen to this 2? It would turn negative. And what would happen to this k? It would turn positive. And what would happen to this 3 if I factored out a -1 to join that 3? Well, what I would have is a -3, and that -k is going to turn positive, and that +2 is going to turn negative, and then it's going to be over k plus 2, and then k minus 2. So that's kind of a unique, interesting situation. But if you have a situation like this, where you have almost the same factor on top and bottom, except for the signs are reversed, we'll divide -1 out of one of them, or factor -1 out of one of them, and then you're going to have the same factor. Now we can cancel the k minus 2's. And I'm left with -3 over k plus 2 as my answer. So that's simplifying. See you in the next one.